Greetings to you all. My name is Kim Hurry, and for this course, Physical Health 161, Environmental and Human Health, taught by Dr. Quad. This end of the year project, I chose to focus on how air pollution increases the risk of atherosclerosis in the elderly American population. First things first, air pollution is a growing epidemic in contemporary society. According to the World Health Organization, 9 out of 10 people worldwide are living in areas where air quality exceeds WHO's guideline and limits of healthy air. Concurrently, air pollution is associated with 7 million premature deaths annually. There are many air pollutants in our contemporary society, including but not limited to carbon dioxide, nitrogen oxide, ground level ozone, particle pollution such as pollen, sulfur oxide, volatile organic compounds or VOCs, and heavy metal such as cadmium, lead, and mercury. Many of these pollutants are associated with various health effects in the general human population, long-term and short-term. Some short-term effects include pneumonia, bronchitis, irritation of the nose, throat, eyes, and skin, headache, dizziness, and nausea. Long-term effects include heart disease, lung cancer, respiratory disease, and damages to nerves, brain, kidney, liver, and other organs functions. A recent study has shown that air pollution could correlate to birth defects too. Air pollution can cause various health problems, but for today we'll be focusing on its effect on the cardiovascular and respiratory system, especially in regards to its association with atherosclerosis. What is atherosclerosis, you might ask? It is the buildup of fat and other substance in and on the arterial walls, resulting in obstruction of blood flow. Atherosclerosis is linked to long-term exposure to fine and coarse particles, such as nitrogen dioxide, elemental carbon, particulate matter that are 10 microns or smaller in diameter from various sources. However, traffic-related air pollution is a significant contributor to these particles. It is closely associated with mortality and morbidity due to cardio and respiratory disease. Of the various contributing factors to atherosclerosis, particulate matter 2.5 microns and smaller has the most significant impact. Particulate matter 2.5 microns and smaller increases the risk for development of atherosclerosis, which is a key factor in cardiovascular disease development. Concurrently, study has shown cardiovascular mortality is increased by 10.6% for every 10 microgram per cubic meter increase in particulate matter smaller than 2.5 microns. Particulate matter 2.5 microns and smaller increases one chance to gain atherosclerosis due to how it impairs high-density lipoproteins particles, cardioprotective qualities that help transport cholesterol from lipid-carrying macrophages, which is a vital process in maintaining net cholesterol balance in the arterial walls. Also, study has shown that people with a PM2.5 concentration higher than 5 micrograms per meter cube over a 3-month period are associated with a drop in 0.64 micromole per liter lower high-density lipoprotein particle matter levels. This lower level is closely associated with the development of atherosclerosis and coronary heart disease. Although there is no conclusive evidence showing that the elderly population is more susceptible to the development of atherosclerosis, heart disease, and respiratory disease, data does show that the elderly population is exposed to high concentration and levels of particulate matter of 2.5 microns or smaller. In one study, data show that in a population that is exposed to more than 15.36 microgram per meter cube concentrations of particulate matter 2.5 microns smaller, 48% is from the age group of 70 or above. Considering that this age group only makes up 27% of the total population of the study, there is a slight indication that the elderly population is more likely to be exposed to higher concentration of particulate matter smaller than 2.5 microns.